All right, guys, this is a quick lesson on not mass versus weight. It's on volume and mass. I'm going to define both of those for you, show you a little bit about units of measurement used for them, and well, that'll be about it for this first one. It should only take me about 5 to 10 minutes to go through, and you probably 20 minutes to write things down, think about it, come back onto Google Meet and ask me questions. So the title is Volume and Mass. So volume is the amount of space an object takes up. For example, a brick, a baseball, a glass of water, they all have volume. The two main units of volume can be cubic units, usually for finding the volume of solids, and capacity units, which are used for finding the volume of liquids. Now, I'm actually going to write some things down here. Usually we use milliliters or liters in chemistry for measuring the volume of liquids. And we usually use cubic centimeters or cubic meters if you have something quite large to measure the volume of for solids. And we'll talk a little bit more at the end about some of that stuff. Let's move on to mass. Mass is the amount of matter. Matter is all things, all atoms, everything that takes up space and has mass is matter, and the amount of matter in an object is its mass. It can be measured using a balance or scales. Weight and mass are not the same thing, they are different. The weight of an object is the pull of gravity, so they are different. We use it incorrectly all the time. We say this weighs this and that weighs that. But weight is not the same thing as mass. Now, in mass, the standard international unit is kilograms, which is the symbol kg. But in chemistry, since you usually are dealing with small amounts of things, you usually use grams, which is the symbol g. Weight is actually measured in newtons. And you won't get into how to measure newtons until you get into grade 11 or 12 physics. Weight changes with location and mass does not. Now, do I have something that on the next slide? Yes. So if you weighed yourself on a bathroom scale on Earth and then on the moon, you'd weigh less on the moon because the moon has 1/6 of gravity. We've already talked about that this year. So you would weigh less. Does that mean you have less mass, less matter, less atoms making you up? No, because your mass would stay the same. I just need to go back on that. Your mass, there we go, stays the same in both places, and if you think, well, your mass is kind of changing because you're a biological thing, take, my stapler, for example. If I go stick it up on the moon, it will have the same mass, the same matter that makes it up. But if I were to weigh it on a scale, it would seem to weigh less because there's less gravity on the surface of the moon than there is on the surface of the Earth. What else did I want to talk about a little bit? Oh, yes, calculating. I wonder if I can get an extra slide here or not. I can't right now, so I'm going to go out of it, keep my annotations, and I am going to insert a new slide and just make it a blank one. Is fine with me. Actually, you know what? I'm going to go somewhere else. I'm going to go to my whiteboard. There's some old stuff. Don't worry about that. Don't pay attention to that. Let's move me someplace else. And let's talk about volume. Ooh, that pen is a little aggressive there. Let's erase that. Let's talk a little bit about volume. Okay, so for solids, if it gives you the dimensions, like, for example, well, I'm going to, not even for example, the formula for finding the volume of something that's like a rectangular prism, then it's going to be length times the width times the height. For example, if we have a rectangular piece of, let's say, copper. that has dimensions of, let's say, 3 centimeters by 5 centimeters by 2 centimeters. All right, that's its length, its width, and its height. Oh, I should not have gotten myself into trying to draw this for you guys because I am not a very good artist. Yeah, that's not too bad. So this rectangular piece that has the dimensions 3, 5, and 2. So which one's the 3, 5, and 2? I didn't really think about that. Let's say that one's the 2. The depth is the 3, and then the width is the 5. It doesn't actually matter which is which here. You're going to get the same answer anyway. So the volume of that being length times width times height is going to be 3 centimeters times 5 centimeters times 2 centimeters, which gives me a volume. 3 times 5 is 15 times 2 is 30. So that's 30. And when you multiply centimeters times centimeters, you get centimeters cubed. That's the superscript for volume. If we were finding area, then it would be centimeters squared, but volume is centimeters cubed. So that's for solids, or a regular solid, like a rectangular prism. Let's keep going and think about, all right, how about an irregular solid? So, let's say you have some weird chunk of metal that you're trying to find the volume of. How the heck can you do that? You can't measure a length, a width, and a height with a weird irregular solid. So what you do is you drop your irregular solid, I'm just drawing it again, but smaller, into a liquid in a vessel called a graduated cylinder. Graduated cylinder has little markings on it to measure the volume. So let's say, for example, the liquid level, I don't know why I made waves in it. Let's say the liquid level was at 40, I'm going to make it on the other side. Let's say the liquid level was at 40 milliliters before your irregular solid went in. After your irregular solid went in, so now it's kind of sitting at the bottom, your level went up to 53 milliliters. So the example here would say, find the volume of the irregular solid. So if the water level was at 40 milliliters and you dropped your piece in and it went up to 53 milliliters, then the volume is simply the difference, 53 milliliters minus 40 milliliters. Actually, I'm going to rewrite that. I'm going to say the volume equals the difference, just so you guys have that in your notes. So you go 53 milliliters minus 40 milliliters equals 13 milliliters. So you can measure the volume of irregular solids in milliliters. Now you can also say that that's a centimeter cubed, because here's something that we should also add, is that 1 centimeter cubed is actually the same as 1 milliliter. Now, I know this note kind of went off the rails and it's a little messy, but I'm just trying to teach you a couple of the toughest examples you're going to come across in your assignments this week in determining volume. Sometimes you'll get a nice rectangular prism where you just go length times width times height, no problem. Sometimes you're going to get an irregular solid where in the problem it says that it changes the liquid level from 40 to 53, for example. And then you just find the difference and that will give you the volume. Otherwise, there's not really that much that's going to come your way. I'm just trying to think for liquids. Now, usually the volume is just given. It's put into a graduated cylinder. Hopefully I can draw a little bit nicer one than that. If I draw another graduated cylinder, the problem's just going to say it's sitting at whatever it is, 60 milliliters, and therefore the volume is equal to 60 milliliters of that liquid. So there's not really an issue there. It was those first two examples that really I thought might trip you guys up potentially. I think that's all I have to say about that right now. I'll post another video if I think we need it. So let's see what you're up against here. What do we got? Mass and volume. We've done that lesson. I hope you've had time to pause the video and write down everything you want to write down. We're going to look at units of measurement. I'm going to post a second video for that. So actually, I don't need to talk about any of these assignments yet until I have you guys view the second lesson. So that is going to be it for now. There will be a second lesson posted shortly.